In this video, we are going to follow another technician on a service call as he tries to figure out what is wrong with a 20-ton split system unit. Your dispatcher is sending you on a service call to check out a 20-ton split system. The problem reported by the building owner is low cooling capacity. The thermostat is set at 75 degrees and the space temperature is 85 degrees with an ambient temperature of 90 degrees. The compressors and fan have been running for hours, but very little cooling is happening. The tech's preliminary power off and power on inspections do not reveal any obvious conditions that would cause this loss of cooling capacity. The next thing the tech will do is take and record the vital signs and calculate subcooling and superheat temperatures. By recording these vital signs on the refrigerant side troubleshooting form, the tech can now analyze the system to determine what the problem is. The tech also notices that the evaporator is partially frosted. He now looks at the symptoms to find the problem. Looking at the symptoms, we find that our discharge pressure is lower than normal, our suction pressure is lower than normal, our superheat is higher than normal, our subcooling is higher than normal, and our compressor run amps are lower than normal. So our basic symptom analysis chart indicates three problems which can produce this combination of symptoms. 1, a liquid line restriction. 2, low outdoor air temperature. And 3, the TX feeler bulb has lost its charge. We can immediately rule out low outdoor temperature since our outdoor temperature is 90 degrees. So we must look into the two remaining possibilities. So our tech has narrowed down the possibilities to 2. 1, a restriction in the liquid line, or 2, a TXV bulb issue. Since both of these conditions relate to the evaporator, we consult a component symptom analysis chart for the evaporator. This gives us ideas of things to check to determine our problem. So for a restriction in the liquid line, we check the temperature across the liquid line dryer, which should be located near the evaporator coil. We do not have any drop in the temperature across our liquid line, and so our tech rules out a liquid line restriction. Now we are left with inspecting the TXV as the problem. We could have a plugged or stuck TXV, a plugged distributor, or a problem with the feeler bulb. A crude but effective way to check the TXV is to remove the bulb from the refrigerant line and allow it to warm up. If the bulb is good, the TXV will open and flood the evaporator. If it is defective, there will be little or no change in the refrigerant feed to the evaporator. Our tech removes the bulb and there is no change to our conditions. Therefore, the TXV needs to be changed out. After our tech replaces the TXV, the system operation returns to normal and is cooling the space as it should be.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.